Hi everyone, welcome back to another video. This is Pranav from Sri Venkateswara College of Engineering, and in this video we'll be talking about image sensing and acquisition. So image sensing and acquisition is a part of DIP, that is digital image processing, and for us to process any kind of object or to process any kind of image, firstly we'll need a source of illumination and the energy to absorb. We need some kind of sensors. So in this video, we'll be talking about various such things and coming to the introduction part. So the types of images in which we are interested are generated by the combination of an illumination source and the reflection or absorption of energy from that source by the elements of the scene are being imaged. So the illumination may originate from a source that could be an electromagnetic energy such as the radar or an infrared ray or X-rays, and this illuminated energy is reflected from the object that is to be imaged, uh, and it is transmitted through objects. As an example, we can see a light reflected from a planar surface or light reflected from any kind of object that is to be processed, and the scene or the energy that is absorbed, that is through a sensor that converts it into electrical signals. So incoming energy is transformed into a voltage by the combination of input electrical power and sensor material that is present in the sensors that is responsive to that particular type of energy that is being detected. So the output voltage waveform is the response of the sensors, and the digital quantity obtained from each sensor by digitizing its response is what is processed. So going to the next one, there are many types of sensors and sensor arrangements that are used to transform illuminated energy into digital images. And in this video, we'll be talking about single image sensors, line image sensors, and array sensors. So incoming energy that is transformed into a voltage by combination of input electrical power and sensor material that is responsive to the particular type of energy is being detected, and the output voltage waveform is the response of the sensors. So this waveform helps us in formation of the image, that is through another topic, that is sampling and quantization. So and the digital quantity is obtained from each sensor by digitizing its response. So coming to types of sensors, the first one is our line sensor and the second one is our array sensor. A line sensor, we have a 1D arrangement of sensors, and as you can see, the sensors have a panel or some kind of sensitive material that is a filter, and the energy transmit is recepted on that particular sensor, and sensors are powered in, and the voltage waveform outlet is seen. So the sensing material is present inside the sensor, and these sensors can be arranged in our line sensor form or our array sensor form, that is our 2D format. So the more the number of sensors, the better image quality you might expect. Now coming to image acquisition using a single sensor. As we know, any kind of image that needs to be processed is to be in our pixelated format, that is our x and y axis. So in this example, we are seeing a single sensor, that is a photodiode, which is used to obtain a two-dimensional image using a single sensor. The motion should be both in x and y directions, and the rotation of the sensor provides motion in one direction, and linear motion provides the motion of perpendicular direction, forming the x and y directions. As we can see in the image, we have a film and the rotational axis and the linear motion um, on the sensor in between. So combining a single sensor with motion to generate a 2D image. Uh, and this is an inexpensive method that we can use to obtain high resolution images with high precision. Image acquisition using a line sensor or sensor strips. So the sensor strips provide image in one direction, and the motion perpendicular to the strip provides imaging in the other direction. As you can see in the image, the imaged area has a linear motion, and the sensor strip has one motion. So both form to give our x and y coordinates. Image acquisition using an array sensor. In this, individual sensors are arranged in the form of a 2D array, and this type of arrangement is found in digital cameras or CCD arrays. So, in this, the response of each sensor is proportional to the integral of light energy projected onto the surface of the sensor. Noise reduction is achieved by letting the sensor integrate the input signal over minutes or hours or even hours. The advantages are the sensor array is 2D, and the complete image can be obtained by focusing the energy pattern onto the surface of the array. In this, we can see the illumination source, that is our energy that is being transmitted onto the seal element that is to be processed as an image, and the sensor or the imaging system captures the captures the energy, and the energy is then pitched on to an image plane that is internally done, and this is further seen in the output, that is our digitized image, and the digitized image is processed that through further many other steps such as sampling and quantization to obtain the digitized image. So the sensor array is coincident with the focal plane, and it produces an output proportional to the integral light received at each sensor. So the more the light intensity or the energy intensity, the better the quality of the image. So sample image formation model. So images are two-dimensional functions of the form f of x comma y, that is our x and y plane, and the value or amplitude of f at the spatial coordinates is a positive scalar quantity. This depicts the format of the pixels or the arrangement, and when an image is generated from physical process, its intensity values are proportional to energy radiated by a physical source. That means the energy radiated from the physical source or the object that is being captured to be processed as an image, so that is proportional to the better quality of the image that can be processed. So the more the energy received or more energy intensity that is being transmitted from the object, the better the image quality. So as a consequence, f of x comma y must be non-zero and be finite. That is seen in this expression. So that is it for this topic. Thank you guys for watching the video. Hope you liked it.